All right, hi there. We are starting Unit 2 today, and we're going to look at the first part of that unit, which is on something called inductive and deductive reasoning. So it's looking at ways that we reason through problems or ways that we think out a problem. So let's start with inductive. So if you notice there, next to inductive reasoning, there are a pair of eyes there, because inductive reasoning means that you're going to make a generalized statement that's called a conjecture based on what you see or known as observations. Hence the set of eyes that are there, because it's based on what do you see happening. So to do this, we look for patterns. Okay, and this is inductive reasoning. So it's based on what do you see happening, what patterns do you see, or what patterns do you observe happening. So let's take a look at our first example here. Movie show times are at 12 o'clock, 1:30, 3 o'clock, 4:30, and what? So there is a pattern here. I need to figure out first off, what is that pattern? So from 12 to 1:30, that was an hour and 30 minutes. Same thing for 1:30 to 3 and 3 to 4:30. Every hour and a half, hour and 30 minutes, there is another movie time. So if I'm at 4:30, add 1 hour to that, 5:30, and then add 30 minutes, 6 o'clock. And so there is my next movie time. Okay, so we discovered the pattern and we apply it, we use it to figure out what's coming up next. So let's try one for a math example here. Now, not every pattern is going to be adding or subtracting or maybe multiplying the same thing each time. Sometimes we have to go a little deeper with our patterns. So let's see what's going on with this one. So from 0 to 1, that was an increase of 1. And sorry about that, I'm going to make that just a little smaller. So from 0 to 1, that was an increase of 1. But 1 to 3 was an increase of 2. So not the same. 3 to 6, an increase of 3. 6 to 10, an increase of 4. 10 to 15, an increase of 5. So they're not increasing the same amount each time, but there is a pattern happening in the amount that they are increasing. Because if 0 to 1 increases by 1, 1 to 3 increases by 2, well, that increase was by 1. 2 to 3, well, guess what? Another jump of 1. 3 to 4, another jump of 1. 4 to 5, another jump of 1. So sometimes we have to find a pattern within another piece to figure out what should be our next parts here. So sometimes the pattern may not be at level 1. Sometimes we may have to take it another step and figure out what is our pattern there. So same thing. So if I know I need to add 1 more to that first increase, then it should go up by 6. So 15, let's see what we get. Plus 6, 21 would be my next one. Continue my pattern on. Add another increase here. So plus 7. So 21 plus 7 means my next term is 28. Okay, so just keep that in mind. Sometimes, again, our patterns have to go a little bit deeper in order to figure out what might be next. But again, that's all using inductive reasoning. The other kind of reasoning that we have is called deductive reasoning. And notice the little picture over there says rules apply, because we have to base our reasoning, our thought process, off of certain rules. Oops. So deductive reasoning is to make that conjecture based on rules, like it says there, rules apply. We can base our generalized statement or conjecture off of facts that we already know. In geometry, we have the postulates and postulates and theorems that we can use. We haven't used very many yet, but we'll be getting a lot more throughout the rest of the year. And we can also use deductive reasoning with definitions. Deductive reasoning is actually what detectives use when they figure out what happened in their different crime scenarios. All right, they use a lot of deductive reasoning because they have to use the facts about a case, they have to use the rules of the law, and possible definitions of some of the pieces involved with their crimes. Okay, so very much deductive reasoning happening there. So let's see an example. So it says Tim is Veronica's cousin. Since David and Veronica are twins, Tim also has to be David's cousin. So that is true. So Veronica and David, brother and sister. And so together they have a cousin, which is Tim. So he is cousins to both of them since they are twin siblings. So that's a fact. If you have two twins, they have the same mother and father. If we have a cousin to one, then we also have a cousin to the other. So let's see what happens when we bring in a geometry here for a second. Okay, so it says ray CD bisects angle FCA. So here is our vocabulary term that we've talked about, which means make two equal parts. So there's the idea of a definition that I need to know. So if ray CD is the one that's bisecting, then whatever is going on at FCD is going to be exactly the same as what's going on at angle ACD, which is why they say angle FCA is being cut into two equal parts. So the measure of angle FCD will equal the measure of angle ACD. Those two smaller parts will be equal. And again, that's what knowing the definition of bisect does for us. It gives us this extra information. It also lets me know if my measures are equal, then those angles will also be congruent. So let's see how we can use those two definitions, how we can use those inductive and deductive with proving out your conjectures. So if we were to make a statement and we want to figure out whether it is right or wrong, so very much like in science, your conjectures would be your hypothesis. You have to run through your scientific method to see whether or not your statement is going to be true or false with your conclusion. One of the ways that we can prove a statement is true or false is by what's called a counterexample. So a counterexample is an example. And again, this could be a picture, it could be an explanation, could be working out your math problem, any kind of an example you can give that proves a statement or conjecture but it proves that it is false. So if I was to tell you all cars are red, I'm sure you could probably find an example of a car out there that wasn't red. That would prove my statement false. That's an idea of a counterexample. So let's take a look at our example that we have here. So we have the statement, all obtuse angles equal 180. Well, we need to know, use your deductive reasoning to know the definition of obtuse. So our definition is that you need angles, your angle measures have to be between or bigger, let's go with bigger, I like that better. Bigger than 90 but less than 180. So that's our definition. That's where the deductive reasoning comes in. So can I find an obtuse angle that is a value other than 100? And I can. I could have the measure of angle A is 105. That's bigger than 100. That's not equal to 100, but it's still obtuse. I could have the measure of angle B, let's say is 95. That's an obtuse angle, but it's not equal to 100. There's lots of different ways that I could do this. I could even have, let's put one more up here, measure of angle C, let's say is 170 degrees. It's still obtuse, but it's not equal to 100. So there's lots of ways that you can find counterexamples. All that matters is one of them. Can you find one that proves a statement wrong? That's all it takes, is to find that one time when the statement is false, and you get your counterexample. All right, guys, I hope you enjoyed learning a little bit about our kinds of reasoning, our two different types. Be sure to reach out to me if you have any questions, and I hope you guys have a great rest of your day. Bye now.